All right, so here we are for we're going to continue learning about linear equations. You guys have already learned one way to write an equation of a line. That's slope-intercept form. Today you're going to learn about another way you can write an equation of a line. It's called point-slope form. And it's not as common as slope-intercept, but I would say it's the second most common because it's easier to put together than slope-intercept. You don't have to do as much work. You literally need a point, like 2, 3, and you need the slope, and then you can write the equation of the line in point-slope form. We use this actually a lot in calculus because it's the easier one to write. It's much easier than slope-intercept. So we're going to go over what it is today. So this is point-slope form. So it's y minus y1 equals m times parentheses x minus x1. So I'll write it up here in the way, if you're writing it in your notebook, you don't have to write all this stuff. You'd write y minus y1 equals m parentheses x minus x1. So just like in slope-intercept form, m is the slope, right? So you need to know the slope. And then you need to know one point. So the point you know would be, let's say, x1, y1, right? So let's say that's your point that you know. Then that is what you would plug in for your x1 here and your y1 here. Your x and your y's are going to stay your variables, just like you have a y and an x in slope-intercept form. So it's actually pretty easy, because if you have a slope, you plug that number in. If you have a point, you plug those two numbers in, and you have point-slope form. Okay, so you can write down what I did up here in your notebook, or you can write down this thing with all the labels underneath the different variables, if that's more helpful. But we're going to do some examples. So pause if you need some more time to write that down. So here are some examples of point-slope form. This actually shouldn't be here. I'm going to do it again with you. I forgot to delete the answer as I made these slides. So let's say you had to write an equation of a line that has a slope of -1/2. So if I come over here, I know slope is -1/2. And what else do I know? I know that there's this point 1, 5. My point is 1, 5. So 1 is x1 and 5 is y1, right? xy. So now I can put this thing in point slope here. I'm going to write it right underneath this text box because this is point slope form right there. So y is y minus y1. Well, what's y1? 5. Y minus 5. Let's see if I can make this a little bit bigger. Not big enough. Y minus 5. Then we have equals. And then m. Well, m is our slope, which is -1/2. -1/2. Parentheses, x is just x, take away x1. Well, what's x1? x1 is 1, so x minus 1. So this right here is the equation in point-slope form, right? Let's see if I can highlight that. Yes, which matches what you see down here. So that is how you can take the two things, the slope and a point, and write it in point-slope form. This is just another way to write an equation of a line. And you can graph that too, because you can take the point 1, 5, put that point there, and then do the slope of down 1 over 2, down 1 over 2. You'll have the line. All right, let's try another one. What is the point slope form for a line with a slope of 5? Okay, so I can go here. I know m equals 5. What else do I know? And it has goes through the point 4, -5. So x1 equals, I'm going to label it underneath. This is x1, 4. And this is y1, -5. So let's write it. So y minus y1. So minus, well, what's y1? -5. So I'm just going to put -5 in parentheses so I don't get those two negatives mixed up. Okay, minus -5 equals m. M is a slope, that's +5, times x is x, and take away x1 minus 4. Okay, so there's only one thing I need to do to simplify it, which is to get rid of these two minuses. We don't want to leave them here. So hopefully you remember a negative times a negative is positive. So that just becomes +5 equals, and all the rest of it stays the same. And so it's really important to know that because the equation or the formula for a point slope has a minus and a minus, right here, if you see y plus 5, that means that y1 is actually negative 5 because that's the only way you can get this positive here, okay? So you've got to take that into account if you're graphing it from this. All right, let's try these. Slope is 9, x1 is negative 2, y1 is 3. So y minus, well, y1 is 3, equals, the slope is 9. I'm just using this up here to help me. Then I have my parentheses, x take away x1. So x take away negative 2. I'll put that in parentheses. Right? So now the only thing I need to do is get rid of those two negatives next to each other. So I get y minus 3 equals 9. This is still x, and then negative times a negative just becomes plus 2. All right, now let's try this one. It's point slope, y minus y1. Well, y1 is 0. Equals m, the slope is negative 7. And then x take away x1. x1 is 4, so x take away 4. Okay, now I can simplify this because I don't need to write y minus 0. If you take away 0, you still have just y. So the equation here is y equals negative 7, x minus 4. That's it. So if you saw this, you would have to know that y1 is 0. That's why there's nothing there. And x1 is positive 4. Okay, now let's try another one. A line passes through the points negative 2, 5, and 3, 4. What is the equation of the line in point slope form? Okay, well, for point slope form, we need a point. We've got 2, so we're good there. Check, we have a point. And we need the slope. Oh, we don't have the slope, so we've got to find it. So remember how you find the slope? This is why we did that review in the last lessons. To find the slope, you need to do x2 minus x1. Sorry, y2 minus y1 over x2 minus x1. So let's label. I'm going to label this x1, label this y1, label this x2, label this y2. So let's find the slope. y2 is 4. Take away y1 is 5. Over x2 is 3. Take away negative 2. So minus, put my negative 2 in parentheses so I don't mess that up. Okay. 4 minus 5 is negative 1. 3 minus negative 2 becomes 3 plus 2, right? Add the opposite. So that's just 5. So my slope is negative 1 over 5. So now, I'm going to write this here so we can remember that. Now I have my slope and I have a point. So when you're writing it in point slope, you can pick whatever point you want. I can decide to pick this first point or the second point. It doesn't matter as long as it's a point on the line. I'm going to choose this point because doesn't have any negatives in it. So it'll be a little easier for me to deal with. So y minus y1 is 4 equals, what's the slope? Negative 1/5. And then x minus x1, which is going to be x minus 3. So that is an equation of the line and point slope. But I could have also used this other point if I wanted to. If I had chosen that point, my equation would be y. Now y1 is 5, so y minus 5. The slope is still negative 1/5. And then it would be x minus negative 2. X minus negative 2 becomes x plus 2. So both of these answers are correct here. Both of these. If you had chosen to use any point, your answer would be correct. And if you graph those lines in Desmos, if you want to pause and check, if you graph those, it will be the exact same line, right? Because both of those are points on the line. And if you start at them and then have the slope of down 1 over 5, you'll get to the other point. So there are actually more than one way to write a correct equation in point slope form because you can choose from an infinite number of points. All right, I think we have 2 more. Okay, so here is we're going to graph the line. Okay, so here's point slope. So what do we know? We know let me get a text box. We know that the slope is negative 2/3. And then we know that there's a point on this line. X1 is here. But because this is a +1, remember, I know it's the opposite of +1. So X1 is actually -1. And then Y1 is just 3. So if I come to plot that line here, I know I can put a dot at -1, 3, which is here. And then I use my slope, -2/3, to draw the rest of the line, right? So down 2/3, 1, 2, 3. Down 2 over 1, 2, 3, right? And I could keep doing that until I have enough points to draw the line. I'm just going to leave it like that. And it's going to look something like that, right? Okay, one more. Sometimes you'll be given an equation of the line that's in, this one's in slope-intercept form, and you have to rewrite it in point slope. Okay, so how could we rewrite this in point slope? Well, I already know the slope. I know the slope is -1/2. So what is a point on this line? The only other thing we need for point slope is another point. Do we have another point? Well, we have this thing, this +5. What is that +5? Remember, for slope-intercept, that 5 is the b. Well, what is the b? The b is the y-intercept. Remember that? And if that's the y-intercept, what are the coordinates of that point? That means it crosses. If I have this here, and I would have if this was 5, there would be a dot there. That would be the y-intercept, right? So what are the coordinates of that point? Well, the coordinates of that point are 0, 5. Right? So now I have the two things I need to write it in point slope. I have my slope and I have my point. So let's write it. Y minus, well, what's y1? 5. Equals m, the slope is -1/2. Parentheses, x minus x1. Well, what's x1? It's just 0. So x minus 0. So again, I can simplify it and you would end up with this. Y minus 5 equals -1/2 x, because x take away 0 is just x. So you could rewrite it like that. Both of these are correct. Okay, so those are some of the problems you'll be practicing today on point slope form. I'll see you guys next time.